Welcome and thank you for your enthusiasm in the 8th series of Hagi R&D webinar. On everyone's behalf, I also want to thank our amazing speakers and moderator for their willingness to share their knowledge with us in this chance. My best regard to Professor Indra Setiawan from Civil and Environment Engineering of IPB, Dr. Song Yung Chung from Dongbu Engineering, Dr. Eleonora Agustine from Geophysics Department of Universitas Pajajaran, and Dr. Luki Subehi from BRIN Research Center for Limnology. This event is held by Research and Development Department of Hagi with the theme of Strategic Value of Water Resources Management for Environment and Agricultural. This webinar will be presented in 2 languages, English and Indonesian, and the video will also be streamed and uploaded in YouTube. My name is Catherine, Physics Universitas Pajajaran, and I will be the master of the opening by MC, the opening speech from the Senior Vice President of Hagi, speakers and moderator CV reading, followed by presentation from all 3 speakers, then straight into Q&A session led by the moderator, and lastly, we will have the closing. We also have some basic rules that must be followed by every attendees in this room. First, change your name into the format of institution_name. Second, the microphone as the speakers present their material. Third, during Q&A session, please write your request in the chat box by the format of name_institution_receiver +_ the question if you are unable to open your microphone. And last, Q&A session will begin shortly after the presentations end. Without further ado, please welcome Dr. Renat Wiwit Supriyanto as the Senior President of Entrepreneur, Course, and Certification at Hagi to give an opening speech which will start this webinar.
Thank you very much, Catherine. Assalamualaikum warahmatullahi wabarakatuh. Good morning, dear invited speakers, professors, distinguished guests, ladies, gentlemen, and all the participants of this webinar. Thanks to the Almighty God to give us health during this pandemic situation that still not yet ended until today. And as the representative of the association, I would like to welcome you all. And it's very glad to meet you again in the webinar series organized by the Indonesian Association of Geophysicists. And this is the 8th series of the webinar with a special topic on research and development. Yeah. In this webinar series, we choose a very interesting topics today about strategic value of water resources management for the environment and agriculture. So on behalf of the association, we would like to thanks to Professor Dr. Insinyur Budi Indra Setiawan. Thank you, Prof. Budi. Welcome to Hagi webinar. And Dr. Song Yung Chung from Dongbu Engineering. Welcome to Indonesia, although in virtually, but I hope you can feel the atmosphere of Indonesia. So if the situation better, we will invite you to personally visit Indonesia. So thank you very much for your time. And also for Dr. Eleonora, bacanya gimana Bu ya? Eleonora ya, Agustine dari Unpad ini. Ketemu lagi Bu di sini Bu. Selamat datang. Who have been willing to be keynote speakers of this seminar. And of course for Dr. Luki Subehi as the moderator of the webinar. Thank you very much Pak Luki ya, atas waktunya. So this webinar is one of the activity that support one of the vision of the association to become a glue between academic, practitioners, and stakeholders in the field of geophysics, and of course to promote and support
Recording in progress.
Science and technology in Indonesia, especially in geoscience issue. And to all the participants of the webinar, we are very grateful for your participation in the HAGI webinar activities, and hopefully you will enjoy the seminar, and of course to gain valuable knowledge and experience from all the speakers. So once again, thank you and welcome to the seminar. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you.
Okay, thank you very much, Dr. Wiwit, for your opening speech. Before we proceed to the topic, for all the attendees, please open your camera for documentation because Dr. Chung cannot stay with us until the end of the allocated time. Untuk seluruh peserta, saya harap untuk menyalakan kameranya untuk sesi dokumentasi karena Dr. Chung tidak dapat stay gitu ya bersama kita sampai akhir acara. Kemudian diharapkan juga untuk menggunakan virtual background khusus untuk webinar hari ini yang telah dikirimkan via email masing-masing peserta. Baik, terima kasih untuk para partisipan yang telah menyalakan kameranya. Mungkin ditunggu untuk yang lainnya selama 2 menit sampai 9.10 untuk menyalakan kamera. Kepada operator juga diharapkan untuk bersiap mendokumentasikan.
Oke.
Baik, mungkin langsung kita dokumentasikan saja ya Pak. Mangga untuk operator. Untuk layar pertama dulu. 1, 2, 3. Kemudian layar kedua. 1, 2, 3. Lanjut ke layer terakhir, itu ada yang ketiga. 1, 2, 3. Baik, terima kasih untuk operator. Next, let me introduce our moderator for today that will lead today's webinar, Dr. Luki Subehi. To the operator, please share the CV of Mr. Luki. Okay. Dr. Luki Subehi is a senior researcher at BRIN or Badan Riset dan Inovasi Nasional in Indonesia, specifically the Research Center for Limnology. He was graduated for bachelor degree from Institute of Technology Bandung and finished his Ph.D. program at University of Tsukuba, Japan in 2010, followed by postdoctoral program at International Water Resources Research Institute, South Korea in 2014 until 2015. He was active in Asia Pacific Center for Ecohydrology for 5 years as research staff starting in 2011 and has done numerous collaboration with many institutions and universities, such as Laboratory of Water Environment, University of Tsukuba, and Chung National University. Dr. Luki has also been one of the steering committee of World Lake Conference, or WLC, initiator for establishing the Southeast Asian Limnological Network in 2016 and a vice president of SEALNet from 2016 until now. Currently, he is a leader for project for limnological study at Rote Island, Indonesia, member team of Kakenhi project for joint research with CER Kyoto University at Kapuas Upstream Watershed, West Kalimantan, and member team of NRF project for joint research with Chonnam National University at Citarum Watershed, West Java. He also has published more than 70 papers in scientific journals and refereed conference proceedings. Please kindly welcome Dr. Luki Subehi.
Thank you very much, Catherine. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, good evening. Annyeonghaseyo. Thank you very much for all again. I'm very glad to be honored in this webinar as a moderator. So I think this morning is we have a very good speaker, I think, here, because we have many senior speakers and also has many experience in their field. So maybe if you don't mind, I will use in mixed bahasa in English maybe, because in here some of them is in maybe Dr. Chung, I will communicate in English, is okay, and I will also translate for you if someone asks you and some discussion later. And maybe to Pak Budi, Prof Budi dan Bu Eleonora, mungkin kita bisa dengan bahasa ya mungkin selanjutnya. Oke, terima kasih sekali lagi saya terima kasih atas kehadirannya. Terima kasih Pak Wiwit tadi yang sudah membuka acara ini. Kemudian terima kasih pada panitia yang sudah menyiapkan. Jadi mungkin hari ini kita akan sedikit berbicara agak lebih lebih beda ya mungkin dalam hal ini, karena saya pikir geofisika lingkungan khususnya itu memang masih banyak peluang dan tantangan saya pikir ke depannya, karena permasalahan lingkungan sendiri itu sangat-sangat urgent ya saya pikir, apalagi tentang air, di mana kontribusi atau peran dari metode atau instrumentasi dari geofisika ini diharapkan bisa berperan lebih banyak gitu, tidak hanya di bidang-bidang yang sudah selama ini memang ada di eksplorasi atau di geoteknik ya, mungkin di geofisika lingkungan. Nah, mungkin dengan adanya webinar ini kita bisa mendapatkan informasi permasalahan yang ada di perairan dan mungkin kita bisa melihat peluang ke depannya. Okay, the first time maybe I would like to introduce each speaker. So let me to share CV from each speaker. First, I want to introduce the speaker from Korea, Dr. Chung. Sorry. You can see this myself. Okay, this is Dr. Chung from Korea. So his professional is water resources management and dam engineering, and also his membership in Korean Water Resources Association, Korean National Committee on Large Dams, and Korean Society of Civil Engineers. And I think he also has been more than 36 years experience in the planning and design, construction management, and hydrological operation of water resources facilities. And his specialty in water resource assessment and development with extensive experience in national and local water resource policies. The background of his educational, that for bachelor degree he graduated from Yongnam University, Daegu, and for master and Ph.D. he graduated from Chung National University in Daejeon. And now he is a technical advisor to Ministry Pak Basuki ya dari PUPR for assisting 65 new dam construction 2018 and 2020. So I think it's very important, interesting subject, I think, because now we, our policy government has more built some many dam and reservoir in Indonesia. So we want to know how the problematic and also how this to solve in the condition in our reservoir. And next, I will also share the second speaker, Professor Budi Indra Setiawan. maybe you can also access from IPB website. You can see here. So mungkin saya dalam bahasa ya. Jadi ini Pak Budi, Profesor Dr. Budi Indra Setiawan. Beliau kaliannya teknik sumber daya air dan minatnya ke prioritas air, irigasi, drainase, neraca, biomasa, dan karbon. Untuk pendidikannya beliau dari IPB tahun 83 dan menyelesaikan S3-nya di University of Tokyo pada tahun 1993. Dan beliau sudah banyak menulis beberapa tulisan. Ini mungkin salah satunya yang bisa saya sebutkan di sini adalah mungkin open digital mapping as a cost-effective method for mapping peat thickness and assessing the carbon stock of tropical peatland. Juga ada developing automatic water table control system for reducing greenhouse gas emission from paddy field. Ini salah satu tulisan beliau yang mungkin bisa menarik untuk kita ikuti dan kita dapatkan informasinya dari beliau. Kemudian next, I will share the last speaker, but it's also important, I think, from Dr. Eleonora. You can see. So this is I can read for you. So Dr. Eleonora Agustine itu dari lewat pendidikannya dari S1 Universitas Sriwijaya Fisika, KBK Geofisika. Kemudian S2-nya ITB Geofisika Terapan dan S3-nya di ITB Teknik Geofisika. Kemudian beliau juga banyak terlibat di beberapa organisasi sebagai Kepala Laboratorium Geofisika FMIPA Unpad, Kepala Pusat Studi Geofisika Eksplorasi Sumber Daya Alam dan Lingkungan, Sekretaris Pusat Riset Citarum, ini mungkin menarik nanti tentang Citarum, dan chairperson beberapa event ya dari international conference yang beliau sudah laksanakan. Kemudian juga dari beberapa penelitiannya sangat menarik bagi saya. Jadi ada beberapa kajian-kajian yang mungkin paling terupdate di sini ada kajian sifat fisika tanah vulkanik dan pembuatan prototipe alat ukurnya. Ini mungkin tahun kedua ya, tahun 2018-2019. Kemudian juga ada rancang bangun alat ukur kesehatan tanah berbasis sifat kelistrikan. Jadi ini menarik ya. Jadi mungkin sudah mulai metode-metode geofisika yang bisa diterapkan di lingkungan untuk kedepannya. Oke, baik, terima kasih. Kemudian untuk mempersingkat waktu, selanjutnya I would like to invite Dr. Chung. Maybe you have already your slide presentation. So for each speaker, we have allocated time around maximum 40 minutes. Yeah, you can more, less than 40 minutes, but not more than 40 minutes.
Okay, thank you. Yeah.
And I will start from Dr. Chung, and then Professor Budi, and then Ibu Eleonora. After all speaker, and we have a slot discussion in the last session. And I also want to talk to our audience that we are lucky because you know that now in Korea is Chuseok Festival. So
yeah.
so actually Korean is holiday now, Chuseok. And as I know that Dr. Chung tomorrow will return to Korea, so we are lucky now we can invite him to share his experience and knowledge about his project as long as Indonesia. So I think this is very good information. Okay, so please, Dr. Chung, it's your time.
Yeah, okay, thank you. Selamat pagi semua.
Okay.
Yes, I am Song Young-jung, introduced by Mr. Luki just before. And my family name is Chung. Yes, I hope you remember my family name. And today I will share my experience in Indonesia for 2 years. But I'm not sure if it is helpful to you because the topic that I introduced today is for dam design or dam construction, sometimes it's a kind of the water resources management field. But your main works is for the geophysics. But I hope it will be helpful for your works, your researches. Yeah. Let me start my presentation. Today I will introduce about the water resource management in Indonesia and my experience for the dam design and construction. First of all, we needed to look at the characteristics of climate in Indonesia. As you know, the seasons in Indonesia is distinctly two categories, wet season and dry season. But in Korea, we have 4 seasons, spring and summer and the fall and winter. But actually the rainfall is concentrated on from mid-June to mid-September. It's a little difference between the Indonesia and Korean. And average annual rainfall is 2,350 millimeters in Indonesia, all over the whole of the world, yeah. And in Korea, it is about 1,027 millimeters. It's less than Indonesia. Rainfall type is also, Indonesia has the 3 types. The monsoon and equatorial and the local type. It is classified by the region. Monsoon type is can be shown from South Sumatra to Timor and the southern Kalimantan, Sulawesi, part of Papua. For the equatorial type is the northwest Indonesia from the northern Sumatra to northwest Kalimantan. Local type is existed in the Maluku and northern Sulawesi. There are many difficulties in managing water resources due to the large variation in rainfall by season and by region. It's very similar to Korea. Before I come to Indonesia, I thought there is no the drought damage in Indonesia because Indonesia is located in the tropical area. So generally, we thought the rainfall is very affluent in the tropical areas. So I didn't think Indonesia have a difficulty for manage the drought. But when I arrived in Indonesia, Indonesia has also have some problem with the drought. This is the type of the rainfall patterns. Monsoon type is equatorial and local type. Korea is only the rainy season. The month is different. It is in the Korea, the 60 or 70% of the annual rainfall will be come down from the mid of the June to the September, mid-September. So it is very, very difficult to manage or control the rainfall. So every years, Korean is suffering from the flooding and the drought. And in Indonesia, there is one of the big problems is the imbalance between the imbalance of the average annual rainfall. Especially it means that the water resources availability it is a big difference in imbalance between the regions. And you can see the Sumatra and the Kalimantan and Papua. And the Kalimantan and Papua has lots of very large of water resources availability because there are not so many population, and this area regions have a big land area. So the total the water resources availability is so much for other regions. Indonesia has more than 5,700 rivers, but among them, only 37 rivers are managed in terms of national strategic importance. There are two types of the water plans, the POLA and the Rencana. POLA is the strategy frame plan. It's made every 20 years. And the Rencana is the kind of implementation plan according to the POLA, such as the feasibility study or basic design. The others, but it is prepared by Balai Wilayah Sungai, and the hydrological data or the water balance data is collected and managed by Balai Wilayah Sungai and the Pusai. And you can see the surface water availability in Indonesia regionally. This is the Papua also, and then Kalimantan and Sumatra has a bigger surface water availability. Water quality of the rivers and lakes in Indonesia is low, as you know. But water quality has been declined steadily in the past decade. But this is the 2012 data. But as I know, there has been lots of improvements of for the water quality of rivers, especially Cidanau and the Ciliong. Because when I visited the Ciliong in 2010, both of bank and the riverbed is covered with the garbage. Now it is very clean. I think so. Now it is only for the Cidanau and then the Ciliong, water quality has been improved, I think. And the only 44 large rivers with class 2 of the water quality standard all of the years. It makes some negative effect, health or tourism, obviously. At first, I couldn't understand why the Maluku, the river water quality in Maluku is so deteriorated. But I realized that there was lots of gold mining, so the water quality has been deteriorated. Flood and also big problems in Indonesia. Flood or damages are gradually increasing due to the people settlement is increased in the flood area. Sometimes the asset value is rising. The flood can be categorized 3 types in Indonesia. It's a fresh flood and the reef flooding and coastal flooding. In the maybe it's kind of the coastal flooding plus and flushing and river flooding in Jakarta case, because the Jakarta has some kind of the regional land subsidence and the seawater level rising, and sometimes from the large flooding from the Cidanau, yes, maybe. And the wide development of urbanization is the widespread heavy rainfalls, resulting in occasional flooding in 40 areas in large cities. Yeah, this is, you can see the flood damage happened in the estuary of a river or the urban area. This is the graph about the droughts. As I told just before, I didn't know there is some big drought damage in Indonesia, but maybe it is caused by the land degradation and the forest fire in Indonesia. Has been the contributed to natural disaster, and then the drought, yeah, and including the floods and the landsliding, but it cannot be the observed rainfalls for a long time. So it can be the cause of the drought. And I can see the data. I can get the data. Actually, the drought damage is much more than the damage from the flood in Indonesia. Sediment is one of the most serious problems in Indonesia. It is a very important thing. So I would like to explain about this later in the dam chapter. Yeah, conclusively, the drought and flooding is caused by the large variation in rainfall by season and by region. It is the fundamental issues. So it needed to it means that there are not sufficient facilities to manage and use the rainfalls efficiently. So it needed to install or construct the dams and the river levees more. And the most serious, one of the most serious problem is the sediment. It is explained later. For the efficient water resource management, integrated water resource management should be introduced. Yes, it's widely in Indonesia. This is my from now I will share my experience in Indonesia for 2 years. It's special. It is a special issues for dam design and the dam construction. This is the data from the World Bank. You can see the Indonesia storage capacity is very low for its GDP per capita. That means that the large of storage capacity should be included. That means that the dam for store the rainfall or the water resources is increased, should be included in the future. So the Indonesian government have plans the dam construction in the from 2014 to 2027, as of the 2014, the total Indonesia have a total of 217 dams. Among them, the BOPR have 186. It means that the BOPR manage the construction, manage the multiple projects. And the private BU and Mentem is has 31 dams. And from the 2040, the additional new dams will be constructed. It is the at government, Indonesian government, the 61 dams to be constructed from the 2020, and the 11 dams will be constructed by 2027. Among the 61 dams, the 43 dams is under construction, and 18 dams already completed. When the 61 dams completed, there is lots of benefit. First one is the irrigation, the increase of irrigation capacity. Irrigation can be increased by the 360,100 hectares, and the dams and reduce the floodings. It's the flooding discharge can be reduced at 13,519 cubic meter per second, and then the raw water supply will be the 46 cubic meter per second additionally, and the renewable hydropower electrics can be produced 253 megawatt. And during my work in Indonesia for 2 years as the technical advice to ministers, I visited and I reviewed more than 20 dams under construction. At that time, I reviewed the design also, and then the construction management. So this is the findings from the dam project undergoing in the Indonesia at that time. There are many things I realized or learned from my experience, but this is the very important things. First one is the hydrological data. Indonesia has not enough reliable hydrological data, so most of the engineers have the difficulty to analyze or to design the dam or what resources management structures. So I suggested first of all to need Indonesian government to install the gauging stations as more and measures, especially when they have a plan to construct the dams. It is the time that the free feasibility study is started or the complete. From then, it is necessary to install the gauging station and measure the hydrological data. Yes, and then in Korea in Korea, we have to the installed gauging station. This at the stage of feasibility study, and we generally the install the flood forecasting, only for the forecasting and warning systems at the stage of construction. So once if the dam has been complete, then we can forecast the flooding and warn once the flood damage and downstream of dams it is possible. Geological condition, yes, yes. And the next is for dam types. In Indonesia, there is no diverse of dam types because the geological condition is not so diverse, not so strong to accommodate every type of the dams. So most of dams constructed or designed or planned as the earth core rock dam. In that case, there are so many problems because of the high water contents in the core, clay core. So sometimes it is very difficult to control the manage the water contents in the core clay. So every the construction site had a difficulty to work. So I think I thought of that how to solve their problems. So I suggested to the government. First of all, the core good quality of core clay is very difficult to get in the dam site. Then it is needed to change the material for what Prof needed to be diverse, such as the concrete or such as the asphalt. And this is the comparison of the dam types. So I suggested the asphalt concrete embankment dams to Indonesian government. Asphalt concrete embankment government is very has very many advantages, but it is not so. It is the innovative dam types. Actually, this type dams has been constructed from the 5,000 years ago, but the modern asphalt concrete embankment dam is constructed in 1962, and now it is the 200 dams constructed with the asphalt concrete embankment dam. The main advantage is first it is the independent of the climate conditions. So there is lots of the rainfall of lots of rainfall day, rainy day. It is no problem to construct this kind of dams, and so it makes very construction management easy, and it can be the construction period and cost more shorter and more effective. And due to the asphalt's the ductility and the viscosity is make the dams is very strong with the earthquake, because sometimes it has self-healing. When the dam asphalt membrane is damaged from the earthquake, it can be the self-healed. So at first the leakage is increased, but it is getting decreased over time. And so Indonesia have problems with the earthquake and a larger rainfall. So this is a good dam type study. This is the construction site. Yeah, how to place the asphalt. Yeah, this is another type, inclined core building. This is good for, this type is very good for the wet core. Wet core is with the high water content clay. Yeah? And the CFRD is the, some dams type is the CFRD in Indonesia. But the rock-churn is very, very strong against the earthquake. But there is some, the concrete face is vulnerable to the earthquake shock wave. This is the example of the damage from the earthquake in 2008. At that time, there was a big earthquake in Setiawan, in China. This is spillway design. Just refer to it. Yeah. And next is the hot issues in Indonesia, reservoir sedimentation. Reservoir sedimentation is one of the most serious problems in Indonesia, and many Indonesian dams are suffering from it. Some dams already lost its the capacity by 50% of original capacity. Its cause is the main causes is the poor land management upstream of them. There is the special cases, Wonogiri Dam and Bilibili Dam and Wolingi Dam and Robogo dams. Nevertheless, mitigation measures may be not enough against sedimentation on the dam, especially at the stage of planning and design. And there is the three categories, three ways to mitigate the reservoir sedimentation. First one is treated the sediment in catchment area, and the second is treated in the reservoir, and the third is the treated its dam. This is the next. I can explain about the special cases. The Wonogiri dams was suffered from the soil erosion by poor land management. Wonogiri Dam is at Upper Soro River basin in Beijing, and it's constructed in 1981. It has been rapidly filled with sediment transported from the catchment, especially from the Kaduang tribe. You can see that this is the schematic. Yeah. There are two rivers. First one is the Kaduang, and the second is the other river basin. So now, as I know, now it is the construction that this countermeasures has been constructed. The one reservoir is to be separated by the installed bank, and then the sediment one reservoir divided can be used for the sediment storage reservoir, and then it is the flush will be flushed through the new installed sediment flushing spirit. And the midterm is also needed to the manage the water seed conservation. And maybe I'm not sure if the construction has been completed. Maybe when I work in the 2019, the countermeasures works was constructed. And for the Bilibili Dam it is suffered. It was suffered from the landsliding upstream of the dams. There was the mountain Mawa Karang and Mr. Salawang. There was the caldera wall and landslide of the mountain Mawa Karang and the mountain Sarangwan, yes, 2004. At the time, lots of the sedimentation flow downstream from the mountains. But fortunately, there was 6 sub dams, so it was very effective. So the reservoir sedimentation is less than the total sediment discharge. And so the case of the William and Rodoyo or the reservoirs is a cause is the eruption of the volcano. William Dam and the Rodoyo Barrage are located in the Brantas River basin in the east of the Java Island. The sedimentation in the Willingi and the Rodoyo reservoir is mainly caused by sediment inflow from the areas most affected by ejecta from eruptions of a volcano. In this case, there are the bypass channels were installed. So is make the sediment prevent the sediment from coming into the dams. So and they have to the flashing during the operation in the flood season and like this. Yes, this is the photos the sub dam upstream of them. And this is the photos upstream area of the Saguri. All area has been developed for agriculture. In this case, under this condition, actually it is not possible to control the reservoir, the sedimentation. And this is the example of the sediment control in the Grobe Valley in Japan. There is the 5 dams developed cascadely in there, but the Unagi dam were suffered from the sedimentation. And after maybe 5 years, or I'm not sure, but many years after the completion, the total storage maybe 60 or 70% of total storage was lost. So they installed a flushing gate. Now it is the operate, the reservoirs operate normally. And the next is a serious problem is the slope stability. A large scale of coast slope in Indonesia dam site haven't designed or planned due to terrain characteristics. Sometimes it occurs the failure. But the main issues, main causes of landsliding seems to be the lack of drain facility for rainwater. Actually, I think this failure will be prevented if we install drain facility for rainfall as well. As you know, sometimes there is the groundwater. In the groundwater, for the groundwater, we have to drain the groundwater, install the internal drain pipe. Yeah, this is the failure slope failure cases. This is typical typical slope stability the scheme. If there is a runoff, then we have to install the ditch and the ditch. And if there is a groundwater, then we have to drain the groundwater is by installing internal horizontal drain. Of course, this is the very basic in civil engineering. And sometimes we have to the soil layering, yes. But it is not planned or designed in Indonesia. Conclusively, I realize it's necessary to share the issues that happened in the dams between the engineers working at other dams construction site, because it's prevent the problems in one dam from happening in other dams. And after have to think about the how to operate and manage the 61 new dams completely. So the consider how efficient to operate the new dams, and I couldn't find out some kind of the standard for the slope stability. Even so, there is lots of problems for the slope stability. So in Korea or in Japan, we have the standard for the slope stability. So we can plan and design according to the standards. I think it is needed to be prepared. And lastly, it is necessary to introduce the capacity building program for planning and design and construction O&M when implemented the design engineering project. Yeah, that's all. Yeah. Thank you for your listening to my presentation. Thank you. Yeah.
Okay, thank you very much, Dr. Chung, your interesting presentation today. I think so many information, I think, especially for me, about how to management and how to for the new building our dams in Indonesia, regarding to concern about the condition in Indonesia, also some climate and slope, geology, and the last also your suggestion about what is standard for slope that you said in Japan and Korea. Maybe I think it's interesting to for me, maybe for us, if background from geology and geofisika, we can learn more about this. Okay, thank you very much. And I think you have good minutes for your presentation, 40 minutes.
Thank you. I try to keep the presentation time.
Yes, thank you. And for everyone, if you, Dr. Cho, you can stay until what time?
I have another meetings at now, 10 o'clock. So
okay.
If you the excuse, yes. I would like to leave this meeting, and then if you have some questions, then you can get it and then send it to my email. Oh. I will send my answers. Okay. By email.
Okay. Thank you very much, Dr. Chung. So maybe later I will share if some question from audience for you, then you can respond later. Okay, thank you very much, Dr. Chung.
Thank you.
Yeah, thank you.
Terima kasih semua. Ya.
Baik, terima kasih. Selanjutnya mungkin tadi kalau ada pertanyaan-pertanyaan tentang kaitan dengan presentasi dari Dr. Chung, silakan bisa nanti dikirim lewat Q&A atau nanti ke panitia ya. Nanti beliau akan berkenan untuk menjawab nanti lewat email ataupun media lainnya. Silakan. Baik, untuk selanjutnya saya mengundang Prof. Budi Indra Setiawan, mungkin sudah siap ya Pak untuk mempresentasikan dengan judul Pengelolaan Das Terpadu Studi Kasus Das Cidanau Banten. Nah, mungkin ini ada sharing juga dari Pak Budi tentang bagaimana pengelolaan di Das Cidanau Banten, terkait juga di sana ada, kalau tidak ada industri Krakatau Steel ya Pak, di sana seperti apa, mungkin jadi informasi yang menarik juga untuk kita semua mempelajarinya. Silakan silakan Pak Budi, 10 menit, silakan.
Terima kasih Bapak Luki, para peserta, wabil khusus para penyaji ya, Bu Agustine, Pak Chung udah brief rupanya ya, dan juga teman-teman lainnya. Terima kasih pada panitia nih, Hagi khususnya yang telah memberikan waktu kepada saya untuk berbagi ya, berbagi pengalaman, berbagi ilmu. Ini semuanya adalah teman-teman baru ya, saya coba lihat satu-satu, kayaknya belum pernah ada yang ketemu atau mungkin juga kelewat ya. Jadi salam kenal ya, salam berkenalan. Mudah-mudahan kalau ada kesempatan lain bisa tegur sapa ya. Kalau ke IPB silakan datang, karena bidang geofisika atau geoteknik juga ada di IPB ya. Jadi IPB sekarang mempunyai Departemen Teknik, Sipil, dan Lingkungan. Memang masih baru ya, didirikan tahun 2008. Saya sedikit promosi dulu ya Pak Luki ya.
Boleh, silakan Pak, silakan.
Tak kenal tak sayang ya.
Betul, silakan.
Mungkin juga ini pesan sponsor juga dari IPB ya. Jadi IPB itu udah bukan ganti nama, tapi branding, jadi IPB University gitu ya. Ini bahasa Inggrisnya, kalau bahasa Indonesia ya IPB saja sama. Ada perubahan. Mungkin teman-teman bertanya-tanya kenapa IPB punya Departemen Teknik Sipil dan Lingkungan kan, sementara kita belum punya fakultas tekniknya, masih digodok gitu. Jadi anaknya lahir duluan, ibunya belakangan gitu. Jadi kita masih diasuh gitu, masih jadi anak asuh. Walaupun demikian IPB memang punya rencana ya untuk melahirkan fakultas teknik yang tentu saja diarahkan ya untuk mendukung pertanian dalam arti luas ya, ya pertanian tanamannya, perikanannya, peternakannya, kelautannya juga ya. Karena tanpa dukungan ilmu teknik, saya kira kita akan terus-menerus ya menggunakan teknologi dari luar gitu ya. Sementara perguruan tinggi lain kan juga disibukkan dengan bidang-bidang lainnya ya. Nah, jadi inilah yang melatar belakangi bahwa IPB sebaiknya juga dilengkapi ya dengan kemampuan engineer gitu ya. Itu mengenai IPB, insya Allah dalam beberapa tahun ke depan Fakultas Teknik sudah bisa diwujudkan dengan dukungan. Sekarang kurang lebih ada tiga departemen teknik yang sudah siap, di samping teknik sipil dan lingkungan, nanti ada teknik mesin dan biosistem, ada teknik industri pertanian ya, ada teknik pangan, 4 sebenarnya. Dan juga beberapa seperti di tempat saya, departemen teknik lainnya sudah mendapatkan JABI IABI ya, International Engineering Certification. Jadi kita udah juga di audit secara internasional ya. Baik, Bapak dan Ibu sekalian, saya ada di Departemen Teknik Sipil dan Lingkungan. Di situ ada divisi namanya Divisi Teknik Sumber Daya Air. Ya, memang ini besar divisi ini. Saya sendiri keahliannya mungkin ya secara besar. Sedangkan minat saya sendiri sebenarnya termasuk ini ya, pengelolaan sumber daya air. dan juga irigasi dan drainase. Termasuk juga nanti ada FI-nya, Skopo, Sinta, banyak adalah Instagram, YouTube ada juga deh. Sambil iseng-iseng jalannya, termasuk beberapa mahasiswa bimbingan saya ya selama ini sudah nyampe ratusan lebih ya. Oke, jadi saya mungkin yang tertua di sini kali ya. Saya lahir tahun 60. Jadi udah kurang lebih 35 tahun ini. Jadi guru ya.
Matang, Pak.
Baik, kita mulai saja. Tolong diingatkan aja Pak Luki ya kalau ada waktunya melewati. Mungkin saya kejar sampai 30 menit ya, tapi kalau terlambat. Tapi tolong 30 menit diingetin aja, karena saya nggak ada clock di sini.
Iya, siapa?
Ya, jadi penelitian ini adalah salah satu kegiatan kami ya, yang dilaksanakan khususnya di Banten. Sebenarnya tidak semua Banten ya, ada das kecil namanya daerah aliran Cidanau. Bisa dilihat itu adalah image-nya ya, tiga dimensi. Ada gunung di belakang ya, kemudian ada genangan air ya. Ini adalah rawa danau, rawa. Ini kalau nggak salah itu ya rawa, adalah kawasan konservasi ya. Kemudian dari mulut atau pintu keluar rawa itu ada sungai ya. Ini sungai yang kecil itu namanya Sungai Cidanau ya. Nggak sampai ratusan kilometer, jadi langsung ke Selat Sunda bermuara ya. Nah, nanti penjelasannya lebih lanjut akan saya sampaikan. Nah, oleh karena itu, karena ini pengelolaan das terpadu, saya kira banyak yang terlibat ya. Tetapi dalam presentasi ini saya didampingi atau bersama-sama dengan teman-teman dari Krakatau Tirta Industri. Itu adalah yang mengolah air ya dari rawa atau dari Cidanau itu menjadi air bersih. Nah, kerjasama kita ini sudah cukup lama ya. Saya sendiri tahun 96 ya udah kecemplung ke rawa danau ya. Dan sampai sekarang alhamdulillah, karena sangat penting sekali merawat das ini, kerjasama kita berlanjut terus ya sampai kurang lebih udah 25 tahun sampai sekarang. Oleh karena itu semua data itu sangat lengkap ya. Ya bertahap kita lengkapi. Tapi saya cukup lengkap dan juga cukup canggih bagaimana kita mengukur ya parameter lingkungan, karena memang itu diperlukan ya untuk justifikasi atau mendukung keputusan di dalam pengelolaan air, terutama dalam perencanaan ke depan proyeksi produksi. Baik, saudara sekalian, kita lanjutkan saja. Kurang lebih inilah bahan yang akan ingin sampaikan. Saya akan perkenalkan sekilas ya Forum Komunikasi Das Cidanau, disingkat FKDC. Kemudian ya seperti tadi disebutkan Pak, sedimentasi itu paling utama ya yang kita hadapi di das. Ya ada erosi, walaupun erosi itu natural ya, tanah di atas itu tidak terjadi perubahan, erosi tetap ada karena hujan kita cukup besar. Ya, karena erosi itu kalau Anda hitung kan pengaruh hujan atau erosibility ya, itu besar. Kadang-kadang kan kita saksikan juga tanah yang das yang lebat pun juga banjir, banyak pohon-pohon bergelimpangan, ya kan? Nah itu juga bukan karena kita membuka. Ya tentu saja dengan adanya pembukaan lahan ya terkendali bisa bertambah parah ya terhadap faktor lainnya. Tapi dengan hujan saja sebenarnya sudah cukup ya kita kewalahan mengatasi sedimentasi, sehingga sering umur dam itu, bendungan itu pendek ya. Dan sekarang zamannya climate change kan, kita tahu jangankan Indonesia, beberapa dam besar pun juga banyak yang roboh ya, di Cina, di Amerika ya, bukan main itu ya. Jadi mau sekuat apa sih kita menahan air itu, ya walau alam ya. Sekarang yang sebesar itu pun juga di Cina itu kan, Amerika, di Eropa juga saya lihat ya. Nah kalau udah bendungan itu jebol, Masya Allah, kayak apa tuh. Jadi itu sangat kita perhatikan, apalagi ditambah lagi kita dengan sedimentasi, erosi. Bagaimana tuh kejadiannya kalau itu dam itu jebol. Bukan hanya air aja kan. Jadi harus benar-benar dipikirkan dalam membuat kondisi iklim. Ini penting tadi ya, iklim, kuantitas dan kualitas air. Nah, kemudian berikutnya kehilangan material tadi ya, akibat dari adanya erosi, sedimentasi. Berarti kan ada beberapa material yang hilang juga, bisa ke muara, membentuk delta dan sebagainya. Ya, sayang juga ya kehilangan tanah kita itu. Nah, di mana Cidanau itu, jadi kalau di sini ada peta Banten, saudara bisa lihat ini yang bentuk seperti apa ya, yang diarsir ini ya, yang warna biru batasannya, adalah Cidanau. Jadi di sebelah sini titik merah atas itu adalah Cilegonnya. Kemudian dari Cidanau ini tadi ya, itu rawa danau ini yang kelihatan. Ya, di sini air itu dibendung, ya dibendung, dinaikkan, kemudian masuk ke rumah pompa, dipompa ya, dipompa, kemudian dialirkan ke kota Cilegon. Ada dua arah, satu ke reservoir, ya itu di Krenceng namanya, sering disebut juga Krenceng reservoir atau waduk Krenceng. Kemudian sebagian juga langsung ke WTP ya. Nah, reservoir ini saya kira kita tahu ini untuk jaga-jaga ya, reserve ya, terutama kalau musim kemarau. Dan inilah yang dilakukan untuk menyadap air. Dan ini kurang lebih jaraknya dari pompa ini ke reservoir itu atau ke Cilegon itu 28 km. Panjang ya. Itu menggunakan pipa sebesar 1,5 meter. Ya, semester dulu itu di pinggir jalan tuh, Pak. Anda dari Cilegon ke Anyer itu ada pipa besar itu, ya di kiri jalan itu. Nah itu kalau dulu kan nggak ada perumahan kelihatan. Nah sekarang udah banyak perumahan segala macam itu. Kadang-kadang ada yang kelihatan, ada yang nggak kelihatan, ya. Timbun gitu loh, artinya ada di bawah. Karena menghalangi jalan kan, menghalangi akses. Dan juga permasalahan, jadi sebelah kiri itu kurang lebih berapa meter itu merupakan jalur pipa, dan itu yang dipunyai oleh PT KTI. Tapi kenyataannya seperti kita ketahui ya, apalagi setelah di timur itu nggak kelihatan pipanya, ya udah digunakan. Jadi kalau ada masalah dengan pipa itu memang agak berat. Itu saya sekalian, nanti saya akan jelaskan lebih lanjut bagaimana WTP itu dan air itu dikemanakan, tapi sebelumnya saya ingin sampaikan juga pada kalian. Ya, ini berita baik ya. Ini dalam mengelola DAS itu kita mendapat 2 award Kalpataru. Bukan main tuh, belum pernah ada. Tapi sampai sekarang juga belum pernah ada tuh ya. DAS, mengelola DAS itu dapat Kalpataru. Pertama itu LSM ya. Namanya Rekonversi Bumi tahun 2010. Jadi peranan LSM itu penting ya di dalam pengelolaan lingkungan terutama, karena kita punya waktu terbatas dan banyak pekerjaan di luar. Ya, jadi kita harus menggerakkan ya masyarakat yang ada di situ, yang secara di situ gitu ya. Alhamdulillah ada namanya Rekonversi Bumi ya. Ya kita kerja sama-sama. Akhirnya karena kiprahnya bukan main hebatnya, nanti kita bisa lihat ya. Itu dapat award 2010, itu namanya Kalpataru Award. Nah, yang sebelah kanan ya itu adalah PT KTI ya, Krakatau Tita Industri pun juga 2013 dapat lagi award. Ya, karena dia adalah buyer. Nanti kita lihat ya, ada buyer, ada seller ya. Ya artinya yang menggerakkan karena dia yang langsung memproses air, jadi dia termasuk di dalam lingkaran stakeholder yang pertama itu. Ya, kalau kita inventarisasi stakeholder itu biasanya ada 4 kan. Nah, ini yang pertama itu sebenarnya masyarakat ya di dalamnya, termasuk LSM. Tapi yang kedua itu sebenarnya KT, perusahaan yang menggunakan air ya. Sampai ujung masyarakat internasional lah yang berkaitan dengan atau ada benang merahnya. Nah, jadi ini sebenarnya lingkar pertama dan lingkar kedua udah dapat award ya dari stakeholder ini. Saya kira udah cukup itu ya. Karena lingkar ketiga, keempat itu bukan orang situ biasanya ya, tapi yang mendapatkan manfaat. Nah, bagaimana pengelolaan ini kita lihat di sini ya. Ini ada source-nya, saudara bisa lihat di kebetulan saya ngambil dari Studi ya, secara detail. Jadi ya intinya kita punya das Cidanau ya, jadi ada Cidanau kita istilahnya itu ya. Kita SK gubernur, ada SK gubernurnya. Kemudian siapa aja yang atau peduli ya, bukan hanya peduli tapi juga mendapat manfaat dari kita merawat ya, atau bekerja sama merawat Cidanau itu. Inilah orang-orang itu ya. Ini harus kita identifikasi. Artinya apa? Artinya kalau Cidanau ini bermasalah, maka penghidupan atau kehidupan orang ini pun juga ya bermasalah. Ya termasuk kita ya, mungkin di sini ada university ya, university, community, private sector ya, government. Di sini ada beberapa pemerintah daerah yang terlibat ya, termasuk pemerintah pusat juga kita libat ya. Karena das itu biasanya kan melintasi administratif dah. Nah, kemudian kita sepakat gitu loh, apa sih yang kita hadapi di Cidanau ini? Pertama, masyarakatnya masih miskin, limpasan permukaan tinggi, erosi tinggi, sedimentasi. Ada juga orang-orang yang mengambil, membuka lahan, membakil pohon, nebang pohon, encroachment ya terhadap ini. Nah, inilah yang akan membawa akibat ya pada suplai air, yang memang suplai air sangat penting sekali karena di situ ya setelah diproses oleh KTI itu digunakan untuk menggerakkan industri besar di Cilegon, termasuk Krakatau di sini. Maka tutuplah Krakatau steel itu, termasuk juga ada petrokimia dan sebagainya itu ya. Mereka itu memang tidak ingin mesin-mesin yang besar-besar itu. Kalau air itu kotor sedikit, sering di overhaul ya. Jadi bukan hanya kualitas kita, tapi kualitas air sangat penting, dan tentunya dengan kualitas yang lebih baik, penjernihnya akan lebih sedikit atau mungkin lebih murah. Itu kurang lebih ya. Kemudian bagaimana strukturnya? Inilah strukturnya. Di situ ada